Hi everyone. In today's video, we're going to be covering section 5.4, which is modeling with linear equations. So today we're still going to be writing equations of lines, but now we're going to write equations of lines that actually model some real-world situations. So more word type problems where we're going to have to pick out information to write our equation. So for today, we're going to just use we're going to be writing equations that have the form y equals mx plus b. So we're going to be using slope-intercept form to model these situations. And so a couple things that I want to point out that are going to make this a little bit easier. When we're reading, we're really looking for two pieces of information. We're looking for our slope and our y-intercept. In general, we're going to be able to pick out our y-intercept because that's going to be kind of like the initial amount or the starting value of our problem. So I'm going to make a note that might not make perfect sense yet, but it will once we start going through this. So I'm going to call that the starting amount. And then our slope is going to be represented by some kind of change. So it's going to tell us how something is changing over time, and that's what we're going to use to fill in our slope. So again, everything we're going to use, or we're going to be writing today, we're going to be using our slope-intercept form. So let's take a look at these problems, again, keeping in mind that we're looking for some kind of change and some kind of starting amount. So for example 1, we have a construction crew that is lengthening a road, so they're laying down some road. It says the road started with a length of 58 miles. So I'm going to highlight that or underline it. It started with a length of 58 miles. So if I'm looking here, that starting amount makes me think this 58 is going to be my B value. Okay, so we started with 58, and the crew is adding 4 miles to the road each day. So that's how the length of the road is changing. They're adding 4 miles, so our slope is going to be that positive 4. So now it gives us what variables. We're not going to use y and x anymore. We're going to be using some other letters to represent this situation. So it says let L represent the total length of the road. So that's our dependent variable. That's going to be our y. So I have L equals, and it says D represent the number of days the crew has worked. So let's see, write an equation relating L to D. Okay, so that's what we're going to do first. So we know that the change, they're adding 4 miles each day. So I have 4. We're using D to represent the days, so 4 miles is added on each day. So for example, on day 2, if D were 2, I would do 4 times 2, I'd be adding 8 more miles. So 4D, and then plus our starting amount was 58 miles. So that's our equation that models this situation. I start out with 58 miles of road, and then I add 4 miles each day. So now we're going to use our equation. It says use the equation to find the total length of the road after the crew has worked 36 days. So 36 is what we're going to substitute for the amount of days in order to find the total length. So I'm going to use my equation. I have 4 times my number of days is 36 plus 58, and then we'll just grab our calculators to find out the total length of that road, which gives us 202. And now with these word problems, we want to be careful to include units if they have them. And we know L is measured in miles, so I have 202 miles of road after 36 days. So that's how these problems are going to work. So let's go ahead and do a few more. Okay, so here's example 2. It said the Sugar Sweet Company is going to transport its sugar to market. It will cost $4,500 to rent trucks, and it will cost an additional $175 for each ton of sugar transported. So I'm trying to keep two things in mind. I want my starting amount or my initial amount, and then plus how much this is going to change. So as I'm reading it, it looks like no matter what, I have to pay $4,500 for the trucks. So that's going to be my initial amount, kind of my starting cost, or my B. Then it says it will cost an additional $175 for each ton of sugar. So as the amount of sugar changes, my cost changes by $175. So that's my slope. And since I'm adding on cost, I know that's a positive slope. So now I've got my M and my B, and I just have to determine my variables. So I know that I'm after the cost, and so we're letting C represent the total cost. And that's going to be dependent on the number, or the amount, of sugar that's transported. So we said we have 175 as our M times the amount of sugar transported, and then we add that initial cost of $4,500. So that's our relationship between C and S. So it cost me $4,500 plus $175 times each ton of sugar that I transport. So now we're going to use this equation to find the total cost to transport 17 tons of sugar. So for this problem, we're going to substitute 17 for S. So I have C equals 175 times 17 plus 4,500. And my total cost is in dollars, so I'm going to make sure my answer is in dollars. And again, we're going to use a calculator to evaluate that. So I get $7,475 is the total cost to transport 17 tons of sugar. Okay, let's keep going. Okay, here's a third example for us. Okay, now we're dealing with money, but we're talking about a savings account. So Boris is putting money into a savings account. He starts with $350 in the savings account, and each week he adds $40. So hopefully, as you're thinking through this, you've already realized our $350 is our B because that's the amount we started with. And then each week we're adding 40, that's our slope. And again, because we're adding 40, we're going to have a positive slope. So now we have S is the total amount of money in the savings account, and W is the number of weeks Boris has been adding money. So if I have the total amount, I know that's going to be equal to 40 times the number of weeks he's been adding money, plus the initial amount, which was $350. And again, we can use this equation to find the amount of money at any given point in time. And so for this example, we're going to find out how much he has after 16 weeks. So that's going to be substituted for W. So if S equals 40 times 16 plus 350, and we get 990, and again, that's in dollars, so we have our units there. Okay, so now here, the rest are really, we have about 3 more problems for you to try. So at this point, it might be helpful to pause and actually try those out. I will walk through them as well, though, in case you still need to see a few more examples. So pause it now if you'd like to try it on your own. Okay, so let's go through these last 3 problems, or just use this to check your answers if you got these down. So the owners of a recreation area are filling a small pond. They are adding water. Again, this is a key to me, this adding water, that's a change. So they're adding it at a rate of 26 liters per minute. So that's my change, or my slope. And again, they're adding it, so I know that's a positive slope. There are 600 liters in the pond to start. That's my starting, or my B value. So it says let W represent the total amount of water. So I have W equals 26 times the number of minutes that I've been adding water. So my variable is T. And then plus the original amount, which was 600 liters. So again, there is my equation of my line. And we want to use this equation to find the total amount of water after 17 minutes. So we're going to substitute 17 for T. So I have 26 times 17 plus 600. And we have 1,042. And again, I'm going to check my units. It says W is the total amount of water in liters, so I'm going to make sure to include those units. Okay. All right, here we have a very similar problem, just the numbers have been changed a little bit. So we're still filling a pond with water. They're adding now at a rate of 35 liters per minute. That's our change, or our slope. And there are still 600 in the pond to start. So let's see. Now we want W as the total amount of water and T is the number of minutes. So our equation is going to be 35T plus 600. And now we're going to use that equation to graph our equation on this coordinate plane. And so we're going to have to be a little careful with our scale here. Okay, so in my equation, I know my y-intercept is 600. So I can see I'm scaled by 100 here. So here's my y-intercept. Now our slope is 35, right, which is just 35 over 1. Now this is a little bit tricky here because we don't exactly have it divided up by 35. So in this case, we'll just have to estimate where I would plot that next point. So let's see. I know this is about halfway, so that would be about 650. So I should be somewhere in between 600 and 650, a little more than halfway. So I'm going to go up about 35 and over 1. So if I'm estimating, it looks like something like that. It's not going to be perfect, but it's an estimate. And so now with those 2 points, we can sketch in our line here. And now, it doesn't make sense, since this is our axis here, our T is time, it wouldn't make sense to have negative time. So I'm just going to show an arrow going this way. So to show that change over time, but that we start at time 0. Okay, I think we've got one more example left. Okay, so this is another, whoops, don't mind the bottom. We're actually going to cut out day 2, so you can see I've crossed that off. It should be crossed off on your schedule as well. So we're just going to focus up here. So another one where we're going to write an equation and then use it to sketch a graph of our equation as well. So we have our Sugar Sweet Company again. Let's see. We're dealing with the cost to the company. So it's going to cost $5,600 to rent the trucks. So no matter how much sugar we transport, we have this initial cost, which is our B, and then an additional $200 for each ton of sugar transported. Again, that's how our cost is changing. That's our slope, and since we're adding cost, it's a positive slope. So C is my total cost, and S is the amount of sugar. So I need to take that 200 times the amount of sugar, and then our initial amount is 5,600. So now, again, to graph this, it's a little tricky because we have some pretty big numbers here. And since our scale up on the y-axis goes by 1,000, again, we're going to kind of have to estimate. So I want to plot my y-intercept, which is 5,600. So I know that's going to be a little more than halfway between 5,000 and 600. So I'm going to plot it about there. Now, our slope is 200 over 1. Again, a little tricky to estimate. If I'm at 5,600, going up 200 brings me to 5,800, so I'm not quite at 6,000. And then I'm going over 1. So you can see on this graph, it doesn't look like a very steep line, but that's largely due to the scale here. So again, I'm going to draw my line. And again, we wouldn't talk about transporting negative tons of sugar, so I don't put an arrow here, but I can put an arrow on the right side. Okay, so that's how we use these linear equations to model some kind of real-life situations, and you'll get more practice with that in the homework.